So James, this is in response to the video that we just posted, that you just posted, and beekeepers have been really good about responding to this new information. One of the first things they come up with is that they can do a new sampling method because they realize that there might be a flaw with the alcohol wash, and they could sample these drones and maybe get some detections on drones versus, sacrificing 300 worker bees in alcohol. We've been working on that for the last couple of years, and really early on we realized that this could be something that could be an applied project out of the basic biological information that we found. And so I used to work with Michael Palmer up in Vermont, and Troy Hall is a good friend, and they allowed us to use their colonies. The only problem was I didn't have funding for the project, so I asked my parents, they live in Eastern Connecticut, if they would drive up to Vermont once a month and essentially sample thousands of bees with us, determining whether you could do sampling of drones versus an alcohol wash. And the thing that we were really interested in was actually, to us, what's the more important question, which is, can you predict a future mite infestation all the way back in the spring? Because if you could do that, to me, that's far better than an alcohol wash that tells you have a hive infestation in August. I can't do much with a colony if it's heavily infested in August. I can treat it, requeen it, feed it, hope it lives the winter. That's the standard practice, right? And I want to do those things so that I can try to get a queen that's not damaged in there, nutritionally make sure it's not stressed in the winter, and it can still make a winter bees, get rid of the mites so it doesn't die, or worse, affect all my uninfected colonies when it does die. I can't do much. It's essentially like a fire alarm telling your house is already on fire. I can't do much with that information, right? It's nice to know my house is burning down. But all the way back in May, if I have a sampling technique that can predict the house is going to be on fire in August, I can do a lot with that information. And so we're asking beekeepers in Virginia to join us on this project, and let me just share a little bit of what we're doing.
Yeah, that'd be great, because there was a lot of questions that were generated about the how-to or the application aspect, and what are the next steps. And like you said earlier when we were chatting about, beekeepers are really great at asking questions and doing interapiary research and looking for solutions themselves, and then taking a question and then running with it and looking for answers based on what they're seeing.
Mm-hmm. Yeah, no, they absolutely are. So, oops, it fast forwarded on me without me wanting it to.
Oh, no.
So we'll go back to, well, that picture that you just saw, it's the spoiler alert for the whole research, which is we found out mites aggregate on adult drones. And not only that, they're mobile within your colony, so they're moving around on the adult bees. And when drones are present in your colony at high numbers early in the season, they tend to, by proportion, aggregate on those adult drones over the worker bee population. And that's just the new information. And this bar graph here is here to show the degree at which they aggregate on adult drones over worker bees. So the males are your drones, and they're green, and orange are your females. And we see by proportion, they really prefer those 1, 2, and 3 day old drones. The 2 and 3 day old drones are the ones they're actually moving on to. So those drones could have been mite free the day before and then gained a mite the next day. And we're just showing by proportion how many of these bees are actually parasitized, which is way more than your worker bees. Now, we did the sampling in Vermont, choosing colonies at random and following them for 4 months. And we handpicked up workers and drones at random from the brood nest. And we saw the data follow the same pattern, which is drones by proportion are more heavily infested, and they're more likely to have a mite on them than worker bees. So to read this graph right here, down here, these are all my non-infested bees. They didn't have a mite on them. That's what we'd expect. And again, by color, our green bees are the ones that are drones, and they were more likely to have detections until we get over into August. And what happens in August? All of a sudden, we no longer have a heavy flow. Colonies stop producing drones, and they shift over to workers. And so this is the underlying science of why we wanted to come up with a new method. And the next is, let me just skip the slide. We'll go right into what the method is. And we're calling it targeted sampling because there is a actual biased sampling technique in epidemiology or in medical, where if you need to find people that aren't well represented in a population, you create a biased sampling method to find those people. And we're like, well, wait, we could do the same thing. Instead of doing a random sampling of bees, let's do a really biased sampling of bees and see if we can identify colonies that are going to have heavy infestations really early on. And so our methods are really simple. You go into your colony and you do a traditional alcohol wash first. You're going into the center of the brood nest, you remove the honey supers, and you look for a traditional frame of mixed cap brood and larvae to do your alcohol wash from. It could look like something like this over on the right. If you can't find that, a frame from the center of the brood nest that's capped brood will be fine. And you're simply shaking it into a pan. I'll always have my scoop and my alcohol out ready to collect the alcohol right away. And I simply collect that sample and then seal it up. Now, this is the new part that we're now asking beekeepers to do. Instead of putting the colony back together, what we want you to do is go back into the colony and grab another frame from the center of the brood nest and hand pick up drones from that frame. Now, we got to point something out particular that drones do. Drones, like older drones, like to aggregate on the outside of the nest. We don't want those drones. My data says those are the drones least likely to have mites on them. We want drones right here from the center of the brood nest, which is going to include a variety of ages. So we're getting a broad variety of drone ages, but it's also more likely to include those 2, 3, 4-day-old drones, which are more likely to have mites on them. And you're just going to pick up the drones. Nice thing about drones is they can't sting you, and they're relatively easy to pick up. You can grab them by the thorax or by the wings. We've visually inspected the drones for mites, but beekeepers come from all different ages and eyesight. So you might not be able to do this. A simple thing is to simply pick up the drone and toss it into an open container of alcohol. I find isopropyl alcohol works very easy. It's cheap, it's quick to pick up at any pharmacy or grocery store, and you can pour a small amount into an open wide mouth container and throw the drones right in. The drones, once they hit the alcohol, just 70%, you can cut it a little bit. They're not capable of crawling out like worker bees can. So you can be confident of just throwing them in there. And we're asking people to pick up 40 drones, up to 40 drones, throw them into the open container. Not all colonies are going to have the same number of drones in them. And this is one of the handicaps of this sampling technique. You could have a colony with no drones. And so this isn't a great sampling technique for those colonies. You could also have colonies with very few drones, and that could be from several different reasons. There could be an underlying issue with the colony, or you could be doing it way too early or late in the season. So keep in mind, you might have that difficulty. We've sampled colonies that had very few drones, but they were still great for getting detections. But you're collecting up to 40. We suggest doing it off of 2 frames and about 20 drones off of each frame. And then all you're doing is agitating that sample after putting a cover on. 30 seconds is honestly enough, but what I would do is shake it for 30 seconds, count the number of mites, shake for another 30 seconds, and see if you get any more mites to dislodge. The nice thing about this methodology is the mites dislodge off the drones very quickly. They're not like worker bees where they can be wedged in there and you really have to knock them off the sample. They seem to come off the drones pretty quickly. And then you just want to record the data. It's that easy. James, before I keep riffing, do you have any questions?
Yeah, one of the questions that had popped up is, that you'd mentioned the handicap between this sampling method, and various other sampling methods. But the handicap you mentioned is that if you got a colony that doesn't have any drones, obviously this is not an applicable method. So what implication does that have to, what motivates me? What's the why would you choose this method to evaluate versus just a standard, alcohol wash on nurse bees, especially if it's not going to, give me data from a colony that doesn't have drones?
Absolutely. So this is a great question. And the first thing I would say is if you're springtime anywhere in the United States and your flow is on and you have a colony with no drones, you have some sort of issue in that colony. Mm-hmm. And I would go looking for that issue. Now, Varroa is a major issue for honeybees, but it's not the only issue. I would go in there and look at your queen status. Do you have a failing queen? Do you have a queen at all? Do you have a brood disease? Colonies with brood diseases can look robust in their population and not be producing drones.
Mhm.
So if I have a colony with blatant chalk brood, I'm not really worried about mites, because my biggest issue at that moment is there's a lot of chalk brood in the colony. If the colony is also heavily parasitized in that they couldn't even get strong enough to produce drones, then the alcohol wash is going to be actually a really good sampling method to quickly make that determination. So the first thing I would say is not having drones is an indicator enough to want to spend more time in that colony and do a further, deeper investigation. You know, as much as I talk about Varroa and think it's the biggest issue with bees, it's not the biggest issue for every single colony out there. So that would be my first response.
So it could provide a discriminatory means to look at other issues that are going on.
Absolutely. Same thing we talked about earlier about drone comb removal. And I think drone comb removal is a great mite control method. It's not a silver bullet, but it's a great method. But you get so much information out of that drone comb. And when I'm removing my drone combs, if I go to a colony, it's got a fully drawn drone comb, I take care of it, go to the next, fully drawn, take care of it, go to the next. When I get into a colony that didn't draw their drone comb, I go and look for an issue. Because I'm looking at the whole yard, I'm like, everyone else could draw their drone comb out, and you couldn't. There's a queen issue, there's a brood disease issue, there's something going on. So I would say the same thing. If you go into a colony, all of a sudden, you know, you're sampling, there's tons of drones everywhere, and you go into one, there's none. Yeah, the sampling method doesn't help you now, but you probably have some sort of other issue that you really need to address in that colony.
Yeah, so we lose the ability to sample them for mites, but we gain the insight necessary to sample them from other issues.
Absolutely. Yeah. And then you're recording the data, and this is where beekeepers can be really helpful. We don't know what the economic thresholds of drone sampling are right now, and this is why you want to pair it with an alcohol wash, so you can get some sort of validation to know what a percentage or infestation on drones is equal to an alcohol wash. And at some point, I'm sure we'll start compiling that data when it's formally run in different areas. But for now, beekeepers can use this for their own field practicum. Especially if you have multiple colonies, you might start to see your own correlation without even doing stats. And that's helpful in and of itself for beekeepers.
You got a sheet you could share if anybody wanted to do this, like something that you're using as an example that we could maybe provide as a link or a PDF for people?
You know what, I do, and it's the one thing I didn't put on my website. I have it. I'll send it to you, and feel free to post it for your group.
Yeah, that'd be great. Yeah, we could get it out there so that folks could have something that's already kind of lined up for them, and they can use that to use these practicums.
Mm-hmm. Yeah, and if you look at the sheet, it's really simple. We're only looking at the major things that I'm concerned about with a colony, which is also how I approach most of my beekeeping. So, for example, if I go into colony, it's queenless, I address the queenless issue. I mean, everyone does this. But if there is a queen issue at all, we address it like right away. If the colony swarmed, we, address it right away, et cetera, et cetera, et cetera. So the field sheet's looking at just really those big ticket items. They're going to be a major problem with the colony. And that also allows me as a researcher to try to figure out, does the sampling methodology work in all scenarios? It might not be predictive of when colonies swarm. Swarming is a great way to halt mite reproduction, because there's going to be a period where they can't re-enter brood cells. And that's just good information for us. We're pretty acknowledging that this is a really nice step towards improving beekeeping management, but it's likely not to be the silver bullet in and of itself. And that's okay by me.
Yeah, so we're going to take 40 drones from the interior brood nest, and we're going to drop those 40 drones. If we can't necessarily use our eyes to evaluate them, like me, I'm at a point where I'm usually wearing contacts out in the field, but I'm supposed to be wearing bifocals. I can't see that, minutia of detail. So I would have to literally take my contacts out in order to see them. So instead of having to see them, I could just take those drones and drop them in the alcohol.
Yep, exactly. And so when we're doing it, with my family and I are doing it in Vermont, we get a little bit more resolution than beekeepers we're going to get by just throwing in alcohol, because we're hand inspecting every single drone. We can actually look at how many multiple detections we had. So if I sample 40 drones and 5 of them had mites on them, 5 different drones with mites, I'm going to get that from my data and how I collected it. Whereas if you just take 40 drones and throw them into alcohol and you get 5 mites, you don't know if that came off of 1 drone, 2, 3, 4, or 5 drones. So you lose some of that resolution. But what do you gain? Well, 1, it's quicker, and 2, you're more likely to engage in the sampling method. It's just easier. 3, anyone can do it, because if your vision's impaired, you don't have to rely upon trying to find mites on drones. By the way, drones are really big compared to workers. It's far more difficult to find the mites on them. And we call it doing yoga with drones. We bend them over, we look right up underneath their head, in between the thorax and the head. They'll hide there. It's not the chin, but if you think, oh yeah, that was something. I had to throw away a whole field experiment, because as I was going, I was like, they're right up underneath there. How many of these have I missed? And luckily it was the first one I did. But yeah, they'll hide on a lot of different spaces on the drones. So we got really adept at looking at these drones and finding and spotting the mites. That's not just on their thorax, it's not just in the feeding position, but they also seem to have these resting positions. We don't know what to do with that new information, but it's there. So
Well,
that's
not yet. So that's one other factor that kind of complicates, the evaluation process, but you have an answer to look thoroughly. For me, the complexity is that drones buzz very loudly. And, when they get to buzzing, that if you're not accustomed to picking up a drone and holding it, it could become unnerving. So you got to kind of practice at it. So picking up 40 drones could get you, on your way to success, but it's going to be a small curve, I think.
Yeah, and so hey, if your viewers aren't familiar with this, you're bringing up a really great thing about drones, which is they buzz, they vibrate their thorax, and it creates this buzzing sensation. So they won't sting you, but it might surprise you.
Yeah.
Not all drones buzz though.
Really?
Yeah, so your newly emerged drones won't buzz, and under 3 days they don't buzz. So when we were collecting our data, we would actually identify drones as newly emerged, non-buzzy, or buzzy.
Really?
And we made those differentiations as well. We're not asking beekeepers to do that, but when you pick up the ones that buzz, and you can feel it through your hand, those are very old drones.
Okay.
You might pick up some that very lightly buzz. They're still younger drones. And that's where I really encourage going to that center of the brood nest. You're gonna get a wide variety of ages of drones. And that's probably the best way to sample. Whereas if you only did the outside of the brood nest on those honey frames or pollen frames on the outside, you're going to get the oldest drones, and you're picking a very small part of the adult drone population, and also the one that's least likely to have mites on them.
So I in perspective, if I want to pick up a drone, like let's say this is it's a bottle cap. So I pick up the drone, its wings are on the outside. I want to kind of come down with my thumb and my index finger and kind of come down around the wings when I pick it up like that. Am I picking it up around the thorax, or am I grabbing it on the abdomen?
I'm in the habit of just picking up bees by the wings, because I'm so used to doing it as a researcher. My parents and I, we picked up over 30,000 bees for this project. My assistants here in Maryland and I picked up thousands of bees and inspected them. So we just constantly we got so practiced at just picking up by both wings. The nice thing is with drones, they can't sting. They'll poop on you, but they can't sting. So whether you grab them by the wings or the thorax, it's not going to matter. Also, to be a little apathetic about it, you're quickly tossing them in alcohol. So, I'd say pick it up, be done with it, and move along. There's going to be a small number of the beekeepers that are going to be allergic to drone poop.
Really?
Yeah, it's a thing. So, that's the other unfortunate thing about the sampling method.
Drone poop allergy. That's a new one.
Yeah, especially if you're like relaying it to your doctor for the first time. Do you have any known allergies?
Drone poop. I'm probably going to do that just because it's going to be fun. My doctor happens to be a beekeeper, so he'll know what I'm talking about.
Great.
All right. So I got 40 drones, and let's say I choose the more complex route, and I don't want to put them in the alcohol, and I'm just evaluating them. Did you have any tricks or tips that you found would be helpful when you were picking them up and then setting them maybe back down in the colony, and not picking up the same one twice?
Well, when we did the work in Vermont, every single drone we picked up died. And
Okay.
we euthanized them in alcohol. And the reason we did that was we had to make sure we had to also make sure we didn't miss mites on drones. So by placing them in the alcohol, we'd eventually see if we made a mistake and missed a mite. So that was very important.
Okay.
The next thing is, if you don't want to sample it again, you'd have to make some sort of container that you can put the drone in. I'd say just euthanize them, to be a little apathetic about it. You know, it's that much quicker. And yeah.
It's just a higher degree of efficiency, you know, and so most folks are gonna be struggling with getting the drone, picking up the drone, dealing with the buzzing, potentially developing an allergy to drone poop. Let's just get them up off of the frame and into the.
Yeah, and you're also going to have some beekeepers that only do beekeeping in leather gloves. This is not a great method for you. It really isn't. And there's some beekeepers, probably like in the Southwest, who are going to look at this sampling methodology and be like, not with my bees. And I get it, right? You know, it's not going to be universal, and that's okay. But for a lot of us, it's going to work out well.
And we're looking for the data, so I mean, we're on a mission.
Yep.
Great. All right. So
let me and hey, let me jump into another reason why we would want to do a sampling methodology like this. And this is something that's going to be in an AV article in June, but I actually want to do this sampling early in the season and identify colonies that have high mite infestations. But when I say high mite infestation on drones, when you compare that to the number of worker bees in the colony during a spring buildup, it's still a insignificant number of mites. Just by proportion, it happens to be high on the drones. Okay. So what I'm getting at is my worker bee cohort is still intact. It hasn't really been damaged yet. So what I'm doing in my apiaries is I'm actually identifying those colonies and then removing them. And by removing them, it's just an epidemiological term. I'm making sure that they're no longer infested. So it could either be physical removal, euthanization, or a full effective treatment. What I'm choosing to do is the full effective treatment route, where I take these colonies, break them out into nukes, add a queen, and then treat them. Now what happens? Well, this apiary no longer has infested colonies next to my non-infested colonies, and I have a ton of new nukes that are now mite-free or close to mite-free that I get to try my new queens in. So this is what I think is a real benefit of a sampling technique like this, is you're doing early detection, early removal, and you have new and more colonies. Whereas the current paradigm is you do detections, but you don't get you do sampling, but you don't get early detections. And then by the time you do removal or treatment, they've been commingled with these non-infested colonies for so long. And James, this is the thing that I constantly forget to mention. This work has already been well established and done by multiple researchers. Drones are the #1 bee in your apiary that's going to drift into another colony.
Yep.
And I didn't prove this. I'm sure another grad student coming along can. We tried, but it got so tedious. But these heavily infested colonies are probably shedding drones at low rates into nearby colonies, and they're shedding Varroa at low rates through that route to nearby colonies. By doing this early removal, you prevent that. And that's what
there's research that's demonstrated that it's colonies that are local nearby, like within close proximity, that are going to receive a greater portion of that drift.
Exactly. And so like I think it was Newman, Seeley, and Delaplane all showed that just by increasing the distance between these colonies decreases it or increases their survivorship. Here we're simply providing another biological reason why that probably occurs.